Alright, so let's try that power function. So what they did is they added version 2 here. Version. They removed I here, and the initialization of P. Then they said here, P is 1, and well, N is bigger than 0, do minus minus N, and P is P times base, return P. Let's see if that works. Yeah, so that still works. So I think what they're getting at is that here we pass I into the function, which is then here called N inside the scope of power. And if we modify N, that doesn't change I because of how calling functions works. It uses a stack. I think is what they're trying to say. The parameter N is used as a temporary variable and is counted down a for loop that runs backwards until it becomes 0. There is no longer a need for the variable I. Whatever is done to N inside power has no effect on the argument that power was originally called with. When necessary, it is possible to arrange for a function to modify a variable in a calling routine. The caller must provide the address of the variable to be set, technically a pointer to the variable, and the called function must declare the parameter to a pointer and access the variable indirectly through it. We will cover pointers in chapter 5. The story is different for arrays. When the name of an array is used as an argument, the value passed to the function is the location or address of the beginning of the array. There is no copying of array elements. By subscripting this value, the function can access and alter any argument of the array. This is the topic of the next section. 1.9 Character arrays. The most common type of array in C is the array of characters. To illustrate the use of character arrays and functions to manipulate them, let's write a program that reads a set of text lines and prints the longest. The outline is simple enough. While there's another line, if it's longer than the previous line, save it. Then the previous longest. Save its length, and print the longest line when the while loop is done. This outline makes it clear that the program divides naturally into pieces. One piece gets a new line, another saves it, and the rest controls the process. Since things divide so nicely, it would be well to write them that way too. Accordingly, let us first write a separate function getLine to fetch the next line of input. We will try to make the function useful in other contexts. At the minimum, getLine has to return a signal about possible end of file. A more useful design would be to return the length of the line, or 0 if end of file is encountered. 0 is an acceptable end of file because it is never a valid line length. Every text line has at least one character. Even a line containing only a new line has length 1. When we find a line that is longer than the previous longest line, it must be saved somewhere. This suggests a second function, copy, to copy the new line to a safe place. Finally, we need a main program to control getLine and copy. Here is the result. Okay. Let's try that. So what is it? Are we gonna call it get longest line or something? Oh. I'll just call it longest. Include standard IO. Define max line to be 1000. Maximum input line length. Get line. Function prototype. Copy. Print the longest input line. Main. maximum length C so far. Oh. Max is 0 while length of get line max line is bigger than 0 if len is bigger than max is len copy longest line. If max is bigger than 0, there was a line. Longest return 0. Get line. Read the line into S, return length. Int get line. Character array. And lim. I don't know what that's gonna do. For I is 0 is smaller than lim minus 1. N C is get character does not equal ender file, and C does not equal the new line character. S of I C, if C is new line, S of I is C plus I, S of I is the null terminator, return I. So what does this function do exactly? I don't really get line. So lim is the size of S, I guess. And then it loops over S while getting characters from the standard input, and then it puts them in S. Okay. And then if it's a new line, I don't really know what the point of this part is. So here they, at the end of the line, the new line character was not put into the array, so that's why they do that here then. Then they increment I. So this is really like one loop iteration outside of the loop, I guess. And then they put a terminator behind everything. Yeah, okay. Copy from into 2. Assume 2 is big enough. Void copy character 2, character from int I is 0. While 2I is from I does not equal plus I. So let's compile that. It's the first time we got so many errors. Conflicting types for getLine. Why are conflicting types? Because we gave it a different name here? I don't know. Conflicting types for getLine. I don't understand. It's a function that takes a character pointer and an integer and returns an integer. So maybe it is. But like name shouldn't. Oh, okay, I should have read. So there's already a function called getLine in standard IO. Okay, so I guess we'll call it getLine 2 then. I guess when KNR was written, standard IO didn't have that function yet or something. I don't really understand. Okay, now it works. So let's see, we cat longest into our binary, and then it gives us that line, so it works. That's cool. The functions getLine and copy are declared at the beginning of the program, which we assume is contained in one file. Main and getLine communicate through a pair of arguments and a returned value. In getLine, the arguments are declared by the line int getLine, which specifies that the first argument s is an array and the second lim is an integer. The purpose of supplying the size of an array is a declaration is to set aside storage. The length of an array s is not necessary in getLine since its size is set in main. getLine uses return to send a value back to the caller, just as the function power did. This line also declares that getLine returns an int. Since int is the default return type, it could be omitted. Some functions return a useful value. Others, like copy, are used only for their effect and return no value. The return type of copy is void, which states explicitly that no value is returned. getLine puts the null character, whose value is 0, at the end of the array it is creating to mark the end of the string of characters. This conversion is also used by the C language. When a string constant like hello \n appears in a C program, it is stored as an array of characters containing the characters in the string and terminated with a 0 to mark the end. The %s format specification in printf expects the corresponding argument to be a string represented in this form. Copy also relies on the fact that its input argument is terminated with a 0 and copies this character into the input. It is worth mentioning in passing that even a program as small as this one presents some sticky design problems. For example, what should main do if it encounters a line which is bigger than its limit? getLine works safely in that it stops collecting when the array is full, even if no new line has been seen. By testing the length of the last character returned, main can determine whether the line was too long and then cope as it wishes. In the interest of brevity, we have ignored this issue. There is no way for a user of getLine to know in advance how long an input line might be, so getLine checks for overflow. On the other hand, the user of copy already knows or can find out how long the strings are, so we have chosen not to add error checking to it. Exercise 1-16. Revise the main routine of the longest line program so it will correctly print the length of arbitrary long input lines and as much as possible of the text. Revise the main routine of the longest line program so it will correctly print the length of arbitrary long input lines and as much as possible of the text. Okay. So the problem is, what happens when you, what does happen when you give a line longer than I thought? We could just change this to like 10 and kind of figure out what happens. Oh. Huh. Okay, so so this is really the thing then, right? For so if I is bigger than the limit, what happens then? It just truncates it, right? And it just puts it in a new line and then a 0, so I don't really understand why that doesn't work then. If I like put this up to 10, wouldn't it still find that? Oh no. Right, then our new line isn't longer. Yeah, okay, I get it. So how do we fix that? I mean, we could write a function. Oh, we just, I think the problem is then, so we have to check here then if I is equal to limit. This means that the line is longer than limit. So we just keep on counting, but we don't copy anything over anymore. So then we just do while get car does not equal EOF and C does not equal the new line character. Like that. Or, I mean, here they write equals this way. Is that gonna work? Let's see. Let's try changing that to 10 again. And then enter the longest into it out. No, so that didn't work. Maybe I'm a bit too tired to be programming. So here, why doesn't that work? I don't know. If I is the limit, that means we have a line that's longer than. Oh yeah, okay, this should be C. Because we use C again here. I thought I didn't have to assign it. Oh, because we're not using C in the body of the function, but. So let's try that. Oh. Oh yeah, okay. We should be 10. Let's see here. No. What? Why doesn't that work? I don't get it. I mean, it should be an easy exercise, right? Let's think. Okay, I think we're gonna have to start debugging, which is kind of crazy. I'm not sure if this is gonna work. Oh no. How do you debug something with a pipe in it? I have no idea. I don't think you can do that actually. I mean, there's probably a way, but all right. Oh. Huh. So now it's waiting for my input, I guess, but we're not at the get car yet, so how? Oh, because we said next instead of step. Okay, wait. Okay, let's just do step. So now it's gonna do get line, get car. I mean, so we're just gonna enter A. So 97 is that? Yeah. Okay. So now it's got the A. And it's gonna ask for our input again. Oh, or not. Okay. So. Oh yeah, we should have just. Okay, wait. Okay, let's try that again. Oh, run. Step. So let's do 11 A's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's just do 12 to just be sure, a bit more. And then I do enter. So isn't right? So it's copying all of that, right? Oh, man! I just stepped over it. So now, wait. Oh, this should be limit -1. Oh man, I'm so dumb. Okay. Yeah. But why is that written? Okay, whatever. Oh. Oh yeah, because we're incrementing I here, but then we're still using I. So I guess we have to do this here. Oh, even below that. But we, okay, let's, because now it's going to give us So I guess like this then. Okay. Why does that seg fault? Let's go back to the original get line. So here, if I is limit -1, then this loop quits. I mean, we break out of this loop. But then, then C is not a new line character. Right. Why is this exercise so hard? I mean, it should be pretty simple. Okay. So maybe this should be why do we test that it is a new line here anyways? I don't really know why we do that. Let's not do that. But then I still don't get why seg faults. Okay, let's. Oh man, it's so pathetic to have to use the debugger on such a simple exercise, but well, it is what it is. Okay. So now it's going to ask our input. We're going to give it a bunch of A's. Oh. It's going to copy all of that over. Okay, so A's 8, 9. Oh, man. So S is now a bunch of A's. What? It didn't. Oh, this should be a new line? Okay, but it's just a small. Still, it doesn't seg fault though. Just. Oh, so it's gonna seg fault in the copy. Or what? I don't know. So apparently I typed a bunch of A's because it's still going. Oh. Okay, so apparently we typed 44 A's. If len is bigger than max. Oh, I haven't even looked at that. Max is, okay, yeah. So that worked, right? No copy. I really. Okay, so. Copying out a whole bunch of A's. Oh, no, it just keeps going. That's the problem. So it didn't. Huh. So it didn't do this? Or like what? I don't understand. Okay, let's try rerunning. So let's break in the copy function. Let's enter a whole bunch of A's. Okay, so now 2 is empty from those A's. Can we still? No, it's so it does have a null terminator, right? Yeah. So 8. Oh. 10. What? How? Wait, how do I scroll up in this window here? Ah, fuck, I can't. I'm sorry for the swearing, but I just did it up there and wow, I really don't get this. Right, so is going wrong. How? Maybe we should do this. Watch from 10. Oh. Okay. Huh? Wow, this is the most confusing bug ever. So I think what's happening is the two arrays are assigned right next to each other. And so the last character of the first array is the first character of the second array. And because I'm going one too far, it copies an A over the null terminator, and then it just loops forever. I mean, then it just copies forever because there's no null anymore. Wow, that's a crazy bug. I think that's what's happening. Okay. So maybe we should stop one earlier. And then we say here, then here, here we should say, this should always be in with a new line character, I think. Okay, so that still didn't work. I mean, at least it didn't segfault, but let's see here. It used to be that for loop, so. Oh, it still is. What? I mean, looking at this, this is 52. Yeah, this is way longer. Oh. This is 59. What the hell? Why is it doing this? Maybe it's returning 0 at some point, which I have no clue why you would do that. I might actually be too dumb for C. Like, I don't know what's going on. we should change this to if I is greater than or equal. That's not going to change anything, I feel like. I mean, we don't change I after the loop, so it can never be above. I wish I could debug that statement. Okay, let's So it is now terminated. So here, I don't understand why. I mean, it's clearly shorter, so my program is wrong, but I just don't understand. Maybe we should do print F. I don't even know how you print a character. Maybe, how do you print a string? Let's see. You just do this. Right, so, oh, here's something wrong. Oh, okay, so we're returning 0. Because we're not doing I++ here. Or plus I? I don't know. I think it should be plus I then, right? Yeah, let's try this. Oh, fuck. Oh, yeah, okay, so now, oh, man. If C is the new line. Or maybe we should say if C is not end of file, then we do all of this. All of this. Oh. Like that. Okay, now it works. Now let's try it with this thing. Yeah, okay, it's working. That's so cool. Wow, that took a while. So maybe we should test to see. So we'll print. Oh, and here it says how to print a string. Man, I should have read my code. I mean, the whole code that they gave me. So now here we also print max behind it. Oh. And now you can see it's 60 lines, 60 characters. Okay, the output is kind of ugly, so let's do it like that. Oh wait, and remove that space. I forgot the string has a new line on the end of it, so. Okay, so that's cool. And if we do it like this, oh, yeah, okay, so that works. Man, okay, that took way longer than expected. Exercise 1-17. Write a program to print all input lines that are longer than 80 characters. Okay. So let's call it longer than. So let's have max line be 1000 again. And now we can, I think what they're trying to teach us with this is that we can just reuse the functions that we've already made. So we can just use getLine and copy. So here we just say, so we don't use max anymore. And then we say if len is greater than 80, maybe we should do define. What do we call it? I'm gonna call that. Large limit 80, or man, print limit of, or lower print limit. Man, that's too long. Print. Let's call it print min print len. Okay. If len is greater than min print len, then we printf %s line, and we don't even need the copy function anymore. Like that. Oh. Okay, so there's nothing longer than 80 characters in there, but let's just change it to 20. And let's run this again. Yep, okay, so that works. Cool. Write a program to remove trailing blanks and tabs from each line of input and to delete entirely blank lines. Which functions are we going to use for that? So let's copy the one we just wrote. What was that called? That thing we just wrote? I don't even. Longer than. And copy it to remove blanks or trailing. So I think the way we're gonna do that is by just like this, printf %s line, and then just modify the getLine function. So then we just do if C is the empty string. Oh, no, it should be in our check then, I think. And C so if C is a blank character, we should just run over it and not increment. Maybe we should just do this with a while loop instead of a for loop. But we could, I think we might be able to write it like this. If C is empty, then we do like that. And else we do that. That is so ugly though, but this should be I as well. So if it's empty, no, that's completely wrong. Because it only counts for the last n, in the last spaces. What I just did then is I didn't allow any spaces, but it's only about trailing spaces, right? Maybe we should always remember the first space that we should always remember the last end. We should always remember the end of the last word, and then if we reach a new line, we can just put a new line there and a 0. I think. So let's introduce a new int called end. I don't know. And then we just say if assume braces first, so that we don't introduce bugs. If I is equal to the empty string, and is I. And it should also remove completely blank lines, so how do we do that? So right now, and then we just do in the end, so what is this again? If the last character wasn't the end of the file, oh yeah, okay. So the else of this statement is really return 0, right? So, and we should also do that if end is 0. Okay, so we initialize end as 0. And then if and end is not 0, right? Wait, no, this should be if I is the empty string. Maybe we should always increment if we read something that is not the empty string, right? Then we should increment end. No, that's wrong too. Man, why is this so hard? Maybe we always have to remember the previous character with that. And then if the current character is a space and the last character was not a space, then okay, let's try that. So we add a new int. Maybe we'll put it after here. Call it LC for last character. And then what should we initialize as? I don't know. So, and then here we can do if I is the empty string and the last character was not the empty string, then we say, oh, excuse me, then we say last is I minus 1. Or we can just set that to I. So now last points to the first space after the last word, right? And then we can just check oh man, here we should say LC is C, right? Oh, yeah. Maybe we should say here like that. Such an ugly program. I don't even know what I'm doing anymore. So, if LC is not a space, if the last character wasn't a space, then we say the current character is last. So wait, so if I is a space, so let's say we have a string. It's like ABC and then a bunch of spaces, right? Then maybe we don't need to do that last stuff at all. We can just be like, oh, we do need to have last, but not the LC stuff. So if C does not equal empty, then last is I, right? So, and now last points to the last character that did not contain white space. Then here we need to check. And last does not equal I. Wait, what? And last does not equal 0. Right? Because then it just needs to, yeah, that's good. And now here we say, instead of I, we say maybe we just do plus I, plus last is \n, and then we increment it again for the 0. I don't know if that's still gonna work with our max line though. I need to think about that for a bit. No, I think that should still work, yeah. Yeah, because so it does compile. That's good. So if we just do a and then do pipe that into a.out, how do we tell if that and then we pipe that into output? Now we can see, yeah, that worked. So, and now what if we do a bunch of spaces, then an empty line, and then hello, and then cat test into a.out. Oh, and pipe that to output. Oh, fuck. Didn't work. Oh yeah, because then okay, I understand why it doesn't work. Because right now an empty line is the same as end of file. Yeah. Maybe we should return -1 if it's end of file and 0 if it's an empty line. Oh no, it should just be if last is 0. I mean, wait, so what happens if we just do that? So let's say we give it an empty line, then last is 0. So we should add here, or wait, and C does not equal empty. I mean the new line. Oh, but that can never happen because of this, right? Yeah. So I think it might just work. I just shouldn't have had that. So if we have just a line that contains only the new line, it doesn't go into this loop, right? Because the guard doesn't work. So last is 0. Then it says sets it doesn't copy the new line character. Wait, so last is 0. Maybe we shouldn't. Maybe we should do last is I plus 1. And then don't increment it here the first time. That's kind of ugly though. So let's see. If if we get an empty line, last is 0, we don't go into this thing. So then S of 0 is the new line. And then return I. Wait, I thought we... That it still returns 0, so... Maybe we should return last here? But, no. Maybe like this, oh. And then here return last. So last can... No. Oh yeah, so then if C is an end of file, it does return 0. Okay, that might work. I don't even know anymore. So it compiles, that's good. And then let's cat test, pipe it into a.out, give it to output. So it did something weird. do that. Oh, and then here maybe we should say if it's greater than 1. Oh no. Then here we should check if len is greater than 1. We do printf. Okay, so that works, I think. Yeah, okay, so we finally finished exercise 18. Then exercise 19. Write a function reverse that reverses a character string S. Use it to write a program that reverses its input a line at a time. Okay. I think we're gonna use longer than. So let's see here. Maybe we need the copy function. Let's instead of using longer than, let's use the first program. I forgot what we called it. Longest. So make this 1,000 again. And then, so how's this gonna work? We get a line, and then it returns its length, so we know the last one, the last character. And then we just loop until the half of the string and always swap the characters. I think that's how we're gonna do it. So I don't think we need copy. My PC is making a lot of noise. Oh. I don't know what's going on. So let's just do that. Reverse. Then takes a string and let's call it lim again because that's what the book likes to call it. Lim. Oh, and that's an int. Oh, we could have just copied get lines. Okay, whatever. So then we go for okay, so first we declare an indexing variable, then we do for I is 0, I is smaller than lim divided by 2, I plus plus, and then we do then we make a temporary character, so T is SI, S of lim minus I is SI, and S of lim, yeah, okay, they should be like that, lim minus I, and then here S of lim minus I is T. So is that, so let's say S is empty. What happens then? If S is empty, then this loop doesn't run, okay. If lim is 1, then 1 divided by 2 is just going to be 0, so it's not going to loop either. If lim is 2, then 2 divided by 2 is going to be 1, so it's going to loop once then. So T is S0. Lim minus 0, so that's going to work, yeah. Okay, I think this might work. Okay, okay, let's try that first before creating the whole copying program. So we just, okay, let's just do it anyways. While, okay, so that's good. And then we just do print f %s reverse, oh no. Then we just do a reverse len, and we print the line. Oh. Okay. Error, len undeclared. Okay, yeah. Oh yeah, line is also undeclared, so that's a character array max line length. Okay, so it compiles. Let's try doing cat, or let's try it with that little testing I wrote earlier. Oh, it doesn't do anything. Okay. Okay. Let's try printing hey here, her line like that. Okay, so apparently reverse just and because it just why does that happen? Maybe. Oh yeah, so S of lim, I mean the limth character of S is going to be the null terminator. So maybe this should all be lim minus 1, right? Everywhere in lim here. So maybe we can just just decrement lim. It's kind of ugly, but okay, so you reverse the first one. But it did remove the new line apparently. And why did it? Oh man, this should be yeah. Okay, we'll just keep it like that. Oh wait, let's cat our test. Okay. Oh, so I forgot. Oh my god. Okay, so this should be reverse. reverse line len. Oh, okay, so it does look like it kind of works, but it removes the new line characters at the end, so there's something. Okay, wait. So let's remove that little line. Or, okay, no, that might be handy actually. But let's just do our simple example. Oh, yeah. So now I think what happens is it puts the new line character up front. So let's just do lim minus equals 2. Yeah, okay, that works. Cool, so we did it. This is kind of ugly, but I mean, I think it would be worse to write lim minus 2 everywhere. We could just declare a new variable. But I don't know, it's just an exercise. It's good enough. Cool, so that works. External variables and scope. The variables in main, such as line, longest, etc., are private or local to main. Because they are declared within main, no other function can have direct access to them. The same is true of the variables in other functions. For example, the variable I in getLine is unrelated to the I in copy. Each local variable in a function comes into existence only when the function is called and disappears when the function is exited. This is why such variables are usually known as automatic variables, following terminology in other languages. We will use the term automatic henceforth to refer to these local variables. Chapter 4 discusses the static storage class, in which local variables do retain their values between calls. Because automatic variables come and go with function invocation, they do not retain their values from one call to the next, and must be explicitly set upon each entry. If they are not set, they will contain garbage. As an alternative to automatic variables, it is possible to define variables that are external to all functions, that is, variables that can be accessed by name by any function. This mechanism is rather like Fortran common or Pascal variables declared in the outermost block. Because external variables are globally accessible, they can be used instead of argument lists to communicate data between functions. Furthermore, because external variables remain in existence permanently rather than appearing and disappearing as functions are called and exited, they retain their values even after the functions that set them have returned. An external variable must be defined exactly once outside of any function. This sets aside storage for it. The variable must also be declared in each function that went to access it. This states the type of the variable. The declaration may be an explicit extern statement or may be implicit from the context. To make the discussion concrete, let us rewrite the longest line program with line, longest, and max as external variables. This requires changing the calls, declarations, and bodies of all three functions. Okay, so longest line. Okay, so let's see what they changed here. Okay, so they declare some variables outside of any scope. add extern here, or oh no, extern int. And extern that. Oh, and they removed the comments. I don't know if that's important. Oh. Then they just copy like that. So we'll keep that little thing I added there. Then, okay, they rewrote getLine, so. Wow, this is some weird code. I would never write that like this. Oh, it's just a wrapped line, I guess. It's not that bad. Wow, Vim doesn't even recognize it like that, I think. Or did I make a typo? Oh yeah, I made a typo. Wait. Oh, I think there's a typo in this book. Is that? Huh? Yeah. Wow, that's crazy. So there's just a straight up typo in this code here. Not sure if this is gonna work, honestly, with all that weird stuff there. Okay. Then copy Man, I should have just copied the code instead of trying to modify my own. What is it called again? Longest two. Oh yeah, okay. What? Where is that? Oh, that's what they... Did I type it out? Yeah, they forgot an opening brace there. Okay, let's see here. Okay, what? That's not the longest line. Oh, okay. Oh, wait, yeah, okay. So if we set that to 1,000, and then what? I didn't save it or something? Okay, it works. Wow. That took a while, copying that code. The external variables in main, getLine, and copy are defined by the first lines of the example above, which state their type and cause storage to be allocated for them. Syntactically, external definitions are just like definitions of local variables, but since they occur outside of functions, the variables are external. Before a function can use an external variable, the name of the variable must be made known to the function. The declaration is the same as before, except for the added keyword extern. In certain circumstances, the extern declaration can be omitted. If the definition of the external variable occurs in the source file before its use in a particular function, then there is no need for an extern declaration in the function. The extern declarations in main, getLine, and copy are thus redundant. In fact, common practice is to place definitions of all external variables at the beginning of the source file, and then omit all external declarations. If the program is in several source files and a variable is defined in file 1 and used in file 2 and file 3, then external declarations are needed in file 2 and file 3 to connect the occurrences of the variable. The usual practice is called a header, that is included by include at the front of each source file. The suffix .h is conventional for header names. The functions of this standard library, for example, are declared in headers like standard.io.h. The topic is discussed at length in Chapter 4 and the library itself in Chapter 7. Since the specialized versions of getLine and copy have no arguments, logic would suggest that their prototypes at the beginning of the file should be getLine and copy. But for compatibility with older C programs, this standard takes an empty list as an old-style declaration and turns off all argument list checking. The word void must be used for an explicitly empty list. We will discuss this further in Chapter 4. You should note that we are using the words definition and declaration carefully when we refer to external variables in this section. Definition refers to the place where the variable is created or assigned storage. Declaration refers to places where the nature of the variable is stated but no storage is allocated. By the way, there is a tendency to make everything inside an external variable because it appears to simplify communications. Argument lists are short and variables are always there when you want them, but external variables are always there even when you don't want them. Relying too heavily on external variables is fraught with peril, since it leads to programs whose data connections are not all obvious. Variables can be changed in unexpected and even inadvertent ways, and the program is hard to modify. The second version of the longest line program is inferior to the first, partly for these reasons, and partly because it destroys the generality of two useful functions by writing into them the names of the variables they manipulate. At this point, we have covered what might be called the conventional core of C. With this handful of building blocks, it's possible to write useful programs of considerable size, and it would probably be a good idea if you paused long enough to do so. These exercises suggest programs of somewhat greater complexity than the ones earlier in this chapter.